Good morning and welcome to Extreme.js 2025. My name is Alon Mureinik and I work for Black Duck, where I manage the R&D efforts for our IAST, or Interactive Application Security Testing Agents. But as fascinating as interactive application security is, this isn't my topic today. Instead, today I want to talk about application security, or at least a very small aspect of it, specifically DoS attacks. And for those of you who are kind of cringing right now, no, I don't mean that outdated operating system. I mean this kind of DoS, denial of service. So if we go straight to the horse's mouth, OWASP defines denial of service as an attack that is focused on making a resource, such as a site, an application, or server, unavailable for the purpose it was designed. Now, DoS attacks usually aren't the attacks you hear about. They aren't the, if you'll excuse the terminology, the sexiest attacks where you steal all the private data or something like that. But they are, as we will see, relatively easy to pull off. And they can be super damaging and just bring your application to a screeching halt. So just to focus this talk, a lot of you hear DoS and think about DDoS, distributed denial of service, which is also a very interesting topic and also not what I want to discuss today. Not that it isn't important, it is super important, but preventing DDoS attacks usually happens in the ops layer with scaling your application and rate limits and WAFs and stuff like that, which is great, but probably this isn't the right conference for it. Since this is Extreme.js, and we want to specifically, I want to talk about Node.js, let's focus on the application and the DoS attacks that are relevant in the Node.js world and how we can easily prevent them. So before we jump into any attacks, quick refresher about the Node.js event loop. So this is a gross oversimplification, and I'm sure some of the other esteemed speakers in this conference will read me to filth about it later. But as a gross oversimplification, in Node.js, most of the user code will run in a single thread, which we call the event loop. Node is designed to handle short tasks, which are CPU bound, on the event loop. And once it gets to something longer, usually an IO operation, the quote unquote right way to design a Node application is to delegate this task to the OS, which will be monitored by a worker thread, and free up the event loop to continue with the short tasks that it can handle well. If you design your Node.js application around this architecture, which is what a lot of web servers or web applications do, you can get a blazing fast application. But this design also means that if you kind of ignore these best practices and don't keep the event loop in mind, it is really easy to write a Node.js application which is really fragile, really vulnerable to DoS attacks. In this talk, I want to focus on how this design helps us, how to structure your application around this design, and some pitfalls that you may want to avoid. Before I go into any specific examples, I just want to iterate in the most explicit terms, and I'll repeat this several times throughout this talk. We aren't just talking about speed. This is not a talk about extreme JavaScript, extreme Node.js optimizations. This is a talk about making an application that can't easily be blocked. We aren't just looking at the fastest way to serve a request. We are looking at the way where we can build our application such that even if it does receive a malicious request, that request may take however long it takes, but it will not block the application from serving legitimate requests. In that fashion, your application will be, I wouldn't say immune, but resilient to DoS attacks. Okay, that was a lot of high-level blah, blah, blah. If you'll excuse the technical term, let's see a concrete example. Let's start with something that we all know and love, JSON parsing. So JSON is ubiquitous to JavaScript in general, definitely to Node.js, and probably to any random web application out there. So here you can see a really simple web app written in Express. This is a complete application. You can copy paste it, it will work. This application takes a post request, passes the body as JSON, and returns the number of keys in the JSON payload. Super straightforward. The catch here is that this JSON parsing is done on the event loop. This means that while this application is processing that JSON payload, it cannot stop processing. It cannot answer other requests. Now, from a DoS perspective, we need to ask ourselves, can we tie up this application with a JSON payload? Or how bad will it be? So before I answer that question, I need to address a misconception. You've heard me going on and on about DoS attacks for the last 7 or so minutes, and you might accidentally think that I am a DoS geek, which is false. A DoS geek is someone who is interested in DoS, who gets excited talking about DoS attacks, which I kind of am, but that's not a good representation. I am in fact a DoS nerd. The difference between a DoS nerd and a DoS geek is while a DoS geek would be excited to talk about DoS, a DoS nerd will be excited to talk about DoS and will have the graphs to back it up. So I graphed out the time it would take to handle this request. On the x-axis, I have the length of the JSON string. On the y-axis, I have the time it takes to process it. And we see this is pretty linear. So if we hit this application with a large enough JSON payload, we can indeed tie it up even for several minutes, which is horrible. So as application designers who are conscious about DoS, what can we do? Well, quite a bit. First of all, the cardinal rule of application security: don't allow tainted or user-controlled data in your critical or interesting path. In this case, don't allow this JSON parsing to pass user-controlled data. If you can do that, great. More often than not, this is not realistic. What might be a bit more realistic is to limit the size of this JSON payload. Since we've seen that the time it takes to process it is linear by its size, just limit the size. To what limit? I don't know. Depends on your application logic. You need to know your application, you need to know what inputs are valid and not, maybe allow a bit of buffer, a bit of overhead, but set a sensible limit. And another approach, since we know that the attack is based on tying up the event loop, just do the processing outside of the event loop. Instead of using the built-in JSON.parse, you can use third parties like BFJ or JSON Stream to delegate the parsing to a worker thread. And again, will this be fast? It will not. Will this move the load off the event loop and free up your application so a single large payload won't tie it up completely? It will. So think about those things when you parse your JSONs. Well, anyway, we've seen a linear effect here, which is concerning, but not that bad. Can we see a scarier DoS attack? Well, we can. This is an example, or this is the XML example of an application that is vulnerable to an input bomb, or in this case, an XML bomb, which, now that I think about it, sounds kind of scary and maybe too scary for this conference. Maybe we need to dial it back a bit. This conference is supposed to be fun. So instead of a bomb scare, let's have a couple of laughs. In fact, let's have a billion laughs. So this payload is an example of the XML variant of an attack called the billion laughs attack, excuse me. What it does, it takes advantage of the XML feature that allows you to define entities. So this payload, its entire data is a lol9 entity. But if you look what a lol9 entity is, it's a series of 10 lol8 entities. Each lol8 entity is a series of 10 lol7 entities, and so on and so forth. So, as you can imagine, this expands really quickly from a really small textual representation of this XML. How bad is it? Well, as a nerd, I have a graph for this. So I graphed out the number of lol levels on the x-axis and the sizes of the input of the text and the expanded input in memory. And as you can see, it kicks up really quickly. With 6 lol levels, it's about 3.5, 4 megs. 7 lol levels, the text itself takes about 650 bytes, but expands to 30 megs in memory. 8 lol levels already kicks up to a gigabyte. I haven't graphed it out because I didn't have the space. But it's really, really easy, as you can see, with a very small payload, which would evade most length limits that we talked about, to just completely take over the memory, which is indeed scary. So, what can we do about it? As always, the best defense is to just not be there. If you can avoid using XML altogether, you're safe from XML bombs. Similarly, if you can avoid parsing user-controlled XML, if you know that all the XMLs that you pass are your own hard-coded configuration files and not anything an attacker can affect, you're probably okay. Both of these are like textbook solutions, really nice to have, and in the real world, quite often not realistic. Usually when we talk about vulnerabilities like this, we talk about input that we expect from a legitimate user, but that can be abused by an illegitimate user. So in the real world cases where we actually get XML input from an external source, what can we do? Well, more often than not, if you don't need all the bells and whistles, if you don't need to get an input that allows defining arbitrary entities and recursively referring to these entities, just don't. Either use a weaker parser that doesn't support these capabilities, or configure your parser to explicitly disallow them. For example, no-end false and huge false if you're using a libxml wrapper. And if you can't even do that, if you absolutely have to allow external entities or entities in general, sanitize your input. I won't go into examples, but there are a bunch of XML sanitizers, either in your application or in the layer beforehand, that can prevent most of these issues. Well, as a side note, I will say XML isn't as ubiquitous nowadays as it used to be. Quite often we see it when we interact with legacy systems or legacy APIs, and a lot of you are probably snickering under your breath, saying something like, oh no, these poor bastards who are forced to use XML need to face all of these issues. I use modern formats, I don't have these problems. Well, sorry to break it to you, if you're using YAML, quite often, most YAML parsers, at least a lot of YAML parsers, have the exact same problem. I won't repeat my whole spiel about XML bombs, but just know that YAML bombs are a thing, and most ways to prevent XML bombs will also apply to YAML bombs. Anyway, we've seen how parsing various formats like JSON, like XML, like YAML, that we did not go into the details, can have a DoS effect. Well, let's move away for a second from all these crazy formats and look at something even simpler that we all know and use, like regular expressions. Regular expressions are great, and we use them all the time for all sorts of things. Over here, you can see a very simple application that takes a regex and a string of text and just tests if this text matches this regex. Sounds safe enough. Well, it isn't. Regex has a lot of power that you don't always need. Specifically, PCREs, Perl-compliant regexes, have a feature called backtracking, where a wildcard can refer to a capturing group before it. So if you consider the regex in the comment here, parentheses A++, this is a regex that looks innocuous. It's a couple of characters long, but once you think about it, it's super complex. So for those of you who don't read regexes, this means one or more groups of one or more A's, which is kind of a ridiculous way to say, I want my string just to be a bunch of A's. But think about evaluating a string against such a regex. Let's just take a small 4-character string. The regex engine needs to check if this is a group of 4 A's, 2 groups of 2 A's, a group of A and a group of 3 A's, a group of A, a group of 2 A's and 2 groups of 1 A, and so on and so forth. And that was just for 4 characters. What if it's a bit longer? And of course, goes without saying, all of this processing is done on the event loop. So once again, like the good nerd that I am, I graphed this out. I took a string of A's followed by a single B and evaluated them with the regex. It works kind of okay-ish until about 31, 32 A's. When we hit 33 A's, it takes about a minute. When we hit 35 A's, it takes almost 5 minutes. And 36 A's, I couldn't fit in here because it just killed my computer altogether. Just took up a ridiculous amount of memory and just got stuck completely. So, what can we do about it? First of all, check your regexes. And I'm not going to promote any specific tools, but generally speaking, if you have a regex hard-coded in your code, SaaS tools do a decent job about this. As always, the cardinal rule of application security: don't allow tainted input, user-controlled input, as your regex, which is not always possible. There's a lot of use cases where the end user can input a wildcard in a search box that gets transformed into a regex, but if you can avoid this, great. On the same note, if you have a regex that might be dodgy, don't allow it to evaluate tainted input. Again, this is quite often not possible. And if you can't avoid it, as we've seen, the time to process a string against a regex depends on the length, not linearly, but it depends on the length. Once again, use a length limit. And as always, the best approach is just to not have this problem to begin with. For example, if you don't need all the bells and whistles of a PCRE, of a Perl-compliant regex, think about an engine like RE2. It's considerably weaker. It does not have all the features that you know and love in regexes, but if you don't need them, this is a decent engine that is immune to redos, to regular expression DoS. And of course, as we all know as software developers, the best regexes are regexes written by others. There are libraries like validated.js, which covers a huge number of common use cases like validating if an input is an email address, an IP, an ISBN, a freight container ID, all sorts of crazy stuff I never even heard about. Some of these validations don't even use regexes. Some of them do with regexes which are kind of battle tested, so you don't need to battle test them. If you don't need to reinvent the wheel, just don't. So with that, I think I've shown several examples of DoS effects against user input. The last DoS effect I want to show may not even relate to user input. DoS via storage. So again, I have here a super simple application. You hit an endpoint, it reads a file from disk and returns the content. Sounds straightforward enough. Well, it is, but let's take a quick reminder about doing I/O in Node.js. Generally speaking, there are two ways to perform storage operations in Node.js. The first way is the async way, where you delegate the actual I/O task to a worker thread. So there are traditionally your callback APIs, so your read dir and your write file and so on and so forth. And there are your promises APIs, which don't have a callback, but return a promise. All of these process the I/O on a worker thread. And if you're using any third party to do storage operations like FSExtra or ADMZip or I don't know what, they usually follow the same guidelines for APIs and kind of look and feel very similar. So if we said that there are two ways to handle storage in Node.js, one of them is the async way, the other way is clearly the wrong way. Storage, if you'll excuse the language, can be horrible. If you are not working asyncly and you're allowing a storage operation to block your event loop, you may be blocking it indefinitely. A lot of us don't think about this because we're used to handling relatively small files on our laptops with our SSD and NVMe and I don't know what super cool new hard drives, which are really fast. But we can't depend on that, especially once you start deploying your applications to whatever cloud you're using and you no longer control exactly what storage backs this application. It can be slow, it can hang, it can lag, it can take whatever arbitrary time it takes to process what looks like a simple request. So in no uncertain terms, just take all your storage processing and do it asynchronously. Let a worker thread handle it. And with that, I want to start wrapping up. I've discussed a bunch of different ways that you can attack a Node.js application with a DoS attack. I've discussed a couple of different ways you can prevent these attacks. And I know this was a lot, definitely for those of you who don't usually think or handle these sort of things. So if I want to narrow this entire talk down to a very simple takeaway, remember the Node.js architecture. Remember the event loop. When you're designing your application, design it to cater to this architecture. At best, you'll make it very resilient and immune to DoS attacks. At worst, at the very worst, you spend some time and you architected a better application which scales better. So net win in any case. With that, I'm running out of time. So if any of this resonated with you, I do encourage you to reach out and to continue this conversation. And other than that, the only thing I have to say is thank you. Thank you for taking your time to listen. Thank you for attending Extreme.js 2025. Have a great rest of your conference.